All right, what is up, Play by Programmers? Today we are going to be taking a look at my direction identifier behavior that's going to help us determine the direction a reference point is from our origin. So, for example, if we were setting up this scout to be our origin, and we were maybe trying to figure out where this metal production facility is from our scout, then we would be able to determine the direction that this scout is in on an 8-point axis, right? So you've got northeast, southwest, as well as northeast, southeast, southwest, northwest. And so we're going to use that 8-axis directionality to determine where we're going, where we're looking, and just the general orientation of things from one another. And this is something that's come up quite a bit for me pretty early on in the game. And it's something that seemed a lot more complicated than it actually was. So I wanted to go ahead and share my really basic solution so that you all can use that solution or improve on that solution if you have a little bit of extra time or a little bit of extra knowledge. So this is the behavior basics directional identification behavior. So let's take a quick little look in here. I actually have two completely separate behaviors inside of this. This is my use case example right here. And then this is actually the directional identifier behavior. And so this just uses the difference in the x and y value, so the delta of the x and y value between 2 points, and then determines the direction based on that difference. And so it's actually pretty easy to deal with. The first thing we need to look at is we need to look at how this particular grid is different than maybe a grid that you're familiar with from math. So this is going to be a little bit different than what you're maybe used to from, algebra or geometry or something like that from school. The way these grids work is the positives are actually down and to the right. So instead of y being positive this way, y is actually positive down on your grid. So it's not a huge deal, but it does take a little bit of focus to make sure that when you're using these directionalities, that you understand that this is negative, negative, this is positive, negative, this is positive, positive, and this is negative, positive. Instead of normally you would have positive, positive up in the top right, and then this one would be negative, positive, and then this would be negative, negative over here, and then positive, negative over here. So just a little bit different than what you would normally look at when you were doing like math or something like that. So just keep that in mind as we go through this, because that's important for how we determine what direction we're going in. Now, if we take a look at this behavior, this is best going to be used as a called behavior. And because of that, I've actually gone ahead and put a couple of parameters in. We have two input parameters. We have our origin and our reference. So when you call this behavior, you'll actually be able to input your origin coordinate and your reference coordinate from whatever behavior is calling this behavior. And that just makes everything a lot more flexible and allows you to use this without just copy pasting it all over the place in your code. You'll be able to just call this on any two locations and determine directionality from those locations. And then it has one output that just tells you what the direction is. These other two outputs are actually for this down here. So while we're talking about just the directional behavior, we only need to look at these first, right? We've got our 2 inputs and our 1 output. So let's take a little bit of a look here. Now I've got some extra nodes in the beginning of this that I'm using as a way to safeguard against inputting the wrong thing. So when you input a unit reference, like I've done, where I'm using the unit reference to the scout as the input for the origin, when you do that, you're actually inputting a pointer that points to the scout. So it doesn't actually have a coordinate saved as part of its value. It only has the pointer to the unit that you're referencing. And so in order to get the actual coordinate value, to be able to do your math on the coordinate value, you have to go ahead and get location on that unit pointer and then save that to a variable. So this is our origin coordinate right here because we've gotten its location. And so that's actually really important. And so what I did is I've got this copy right here to take the origin and copy it into this internal origin value. And so if this is a coordinate value, then it'll just do that copy and it'll be fine because the get location will just fail and then it'll just move on. And then if it gets a unit reference, then it gets that location and then moves forward. And so it works either way. It does add an additional 4 nodes to the input, to the behavior, which means it's going to take an additional 0.8 seconds per trip through here because it does 1 node every 0.2 seconds, right? That's what the tick is 0.2 seconds. So we're adding almost an entire second per behavior call here just to run this safeguard. So what I would recommend is actually to take this safeguard out and always just feed coordinate references. But if you don't want to necessarily bog yourself down with that, you can go ahead and keep this safeguard here. If you were to skip this safeguard, then you could actually just pull the origin and the reference directly down into these locations where the origin and reference are. And you don't actually need to copy those values to internal variables at all. You can just use them straight from the parameters because they're there. And that'll save you 0.8 seconds per behavior call and cut your overall behavior time in about half, which would be super cool. So then we're going to look over here and we're going to see just how this behavior actually works. And the way it works is you're subtracting the reference from the origin, right? So it's origin minus reference equals. And so when you get that number, you get the delta, right? The change in the value. So we have to remember, if we go back here, we know that going up and left are negative numbers, right? We're subtracting. So we start here at 2848. If we go up and left one, we get 2747. If we go down and right one, we get 2949. And what that means is we actually get positive values when we're going up and left, and we get negative values when we're going down and right, because we're subtracting the new bigger value from the old smaller value. So that's going to be important because we're going to use whether or not numbers are positive or negative in order to determine what direction we're looking or moving. So let's take a quick little look at that. So we get our delta and then we separate that out because we want to get the delta x and the delta y, right? The change in those values between the two coordinates. And then we're going to go ahead and first thing we're going to do is we're just going to call a compare on x, comparing it to 0, right? So this is just basically checking, is the number equal to, greater than, or less than 0? And we're going to use all 3 of these outputs. So if delta x right? If the change in the x value is equal to 0, then that means we haven't gone left or right at all. And if we haven't gone left or right at all, that means we've only gone up or down, which means we're only doing north and south. So if we look at the x is equal to 0, you'll see that we only have the change in y, right? Delta y. We're only looking at if larger or smaller. If it's also equal, it means we haven't moved at all, and we go right back to the beginning of the behavior. Or we exit out of the behavior because we're not moving, so it doesn't matter. Or we're on top, right? The 2 points are on top of each other, so it doesn't matter. But then if the delta y is larger than 0, meaning we've gone up, right? Because up gives us lower numbers, which gives us positive delta. So if we're not going left and right, and we are going up, then we're going north. And I've just added a little comment here to say this is north. And then if we're not going left and right, and we're going down, because we're getting negative numbers, right? Negative numbers are smaller than 0, then we're going south. I don't know why this says east. It should say south. And then I bet you I changed east to south. Yeah, I did. This is east. We're going to figure it out. And then I bet that I changed something over here too. This is X, this is Y. Okay. Fixed it. We're good. Okay. So, yeah, so we've got north and south. Then we take a look. If X is larger, right? If the change in X is a positive value, that means that we've been moving to the left, right? So these are going to be all of our west values here. And so if X is positive and Y hasn't changed, then we're going straight west. If Y has gotten larger, that means we're going left and up, which is northwest. And if it's smaller, it means we're going left and down, which is southwest. And then if we're smaller, meaning we're going to the right, then we're going to the right and not up or down at all, means we're going straight east. If we're going to the right and larger, which means up, then we are in the northeast. And then if we're going right and down, we're in the southeast. And so just through those two quick comparisons, right? We compare X and then we compare Y. And based on positive, negative, or no change, we can determine all 8 of these axes. Now, I've used colors here to set up the axes. The reason I did that is because I couldn't really find a better way to set those up, because you can't just use numbers for these. You have to use something else. And so I just figured colors was the best. The numbers that are also on there are from a previous test where I was trying to use a single color and a number, but the numbers didn't translate, and so it wasn't working. So you have to use different identifiers, not indexes, right? The numbers are indexes. So I wasn't able to do that. So I just used a bunch of different colors to determine directionality. It's not perfect. One of y'all might be able to figure something better out for that, maybe using an array or something. But for now, this is working for me. So I'm just using 8 different colors to determine the directionality. But that's really it, right? This just determines whether or not you're going straight in one of the cardinal directions or off into one of the diagonals. Now, this does have a limitation. And we'll take a look at that limitation right now. And that limitation is that the diagonals are all of this space that isn't directly north, south, east, or west, right? So from this scout, only this one directional this one wide grid here is actually going to count as north. So all of these, all the way up here is north. But if I get off of that track, even by 1, then it counts it as northeast. And the same is true of east. If I'm going east straight, that's fine. But if I get off by even 1, it counts it as northeast. Now you could adjust the number that you're comparing right over here based on the distance between the 2 points. And you could do some math on that so that you could instead get 45-degree angles that are determining your directionality. But this is a behavior basics, so we're just going to use the straight up directions, and then these diagonals will just be basically everything else. That'll be good enough for our use cases, I believe. Primarily the use case that I think this is for is so that you can rotate offsets for units moving in a formation. So for example, if I didn't have this directionality and I wanted to set up a formation, that's actually really easy to do, right? I can just decide on an offset and I can say, okay, I've got my scout going out and I want 2 transport bots to follow my scout so that they can bring things back when my scout opens up these explorables. And so I set that up, and I set it up where it's +2 on the X and +2 on the Y. And when I set that up, this is where my offset is. This is where one transport is going to go. And then I could set up the other one to be -2 on the X and +2 on the Y. And then that'll set up this other transport right here. And when I'm going north, that works really well because they're behind my scout. My scout has its little laser beam here, so it can defend those other units, and we're good to go. We're happy. But if I decide to go south, then the offset doesn't rotate. And so it's still +2, +2, and -2, +2. So now if I'm going south, my transports are out in front of my scout, right? They're vulnerable and they might get killed. And so now my formation only works when I'm explicitly moving directly forward. Sorry, directly north. And that doesn't do any good. And so what we want to do is we want to rotate our offsets based on that directionality. And that's actually what this down here, which is another different behavior that if you're going to use, you should separate out. It's in the same behavior right now, specifically for the purpose of this example. But if you just copy paste this right out, then you can get this into a different behavior and use it as another behavior call. And all you need is you need the input of the direction. Right now I'm running it on a parameter event, but you would just use this direction as an input, and then you could output either the X and Y separately, or you could combine the X and Y and then output them together as a single parameter. And that'll give you your new offset so that you can run your formations. And so the way that works is really simple. I'm hard coding some values right now. So we're going to hard code the X offset to 2, and we're going to hard code the Y offset to 0. And then we set our default to north, right? So case 1 is north, right? That's the same color, which is this yellow value here. So if my direction parameter changes and it changes to yellow in this switch, then I know that I'm going north. And all I do is I just copy the X offset that I set up here directly to the X output. And then I set up the Y offset and I set it up to the Y output. And I say, okay, we just use the default. And then if I get back a 2, which is east, or a white, which is east, then I can come over here and I can say, okay, if we're going east, we rotate our offset by 90 degrees. And in order to do that, we're going to subtract our Y offset from 0, and then we're going to set that up as our new X offset. And then we're going to copy our X offset to our Y offset, and that'll rotate us 90 degrees. And then when we want to go south, we're going to subtract both from 0. So basically, we're going to invert the offsets. You could also multiply by -1 and get the same effect. But we're going to subtract from 0, and we're going to flip the offset. And then in order to go to the west, we're going to set the old Y offset to the X offset, and then we're going to subtract the X offset from 0 and apply that to the new Y offset. And so this is just some pretty basic, right? It's all addition and subtraction, so that as we're rotating around that origin, based on the direction that that origin is moving, then we're setting up new offsets. And I'll show you how that's going to work right here, right now. So if we take a look in here, I've got 2 locations that I'm running. Now, normally you would programmatically add these parameters in, right? When you call this, when you're in your behavior tree and you call a behavior, right? We can go in here and we can look at direction identifier. You get these inputs, which are the origin and the reference. And so normally, whatever program needs to use this direction identifier would determine what the origin and the reference are. Because I'm running it right now as a primary behavior, I can actually go in and just decide what those parameters are. And I can actually select them right off the map. So I'm going to set my origin to my scout here. And then I'm going to set my other location to this building right here. They were already set that way. And then you'll see, because this is north and east from me, I'm getting the light green, which is the northeast. And then because I was set up, okay, this actually hasn't updated because this parameter hasn't changed. But if we switch right over here, you'll see that this is now north. And this went ahead and changed, right? The direction is now yellow, which is north. And it now says 2x, 3y is the offset. So if we go over 2x and down 3y, you'll see that this is where our offset would lead us. So our our transport would actually be right down here on this location. Now I can't get there because there's something in the way, but that's how that would work. So then we take a look, and let's move over a little. And we move over right here, and we see that changes to northeast, and then we see our entire everything else over here changes. So our offset changes. And so the way this works is we're still going to do that same 2 over 3 back, but because we've rotated our orientation, it drastically changes what the offset is. So remember, when we were going north, we went 2 over 3 down, and that took us to here because we were right here. But 2 over 3 down is right here if we're facing north. We're not facing north anymore, right? We're facing this way. So we use this diagonal. We go 2 over, we go 3 down, and we're now -1, +5 on the offset. And that's how that sets up. And then if we move over here, we're now going to be actually looking in this direction, right? We're now going to the northwest. And so now you're going to see it's a +5 and a +1. And so we do the same thing, right? We're going 2 to the right, right? So 1, 2, and then 1, 2, 3. And that puts us at +5, right? 1, 2, 3, 4, 5, and then +1. Because we go over to the right and down 1. And so it's always the same. We're always coming right off of this right-hand side. We're always oriented in the same way from our origin here. But it just depends on what direction. And so this can be used for a couple of things, right? You can take the direction that the scout is moving. So I could like copy the value that I have right here, and then I can move, and then I can use this second value as my reference, right? So I can have the old position I was in as the origin, and the new position I'm in as the reference, and that lets me know what direction I'm moving in. And using that, then I can send that direction to any other bots that are moving with me, and they can stay in formation no matter what direction I'm going in, because I'm constantly updating that directionality. And that would be part of your base program, right? Your base behavior that would be inputting your old value and your new value just over and over again as you moved around. And then you would feed this direction out to your other bots, and they would rotate their orientations based on the direction you were moving, so that your bots would always be, if they were supposed to be behind your scout, they'd always be behind your scout. And if they're supposed to be in front, they'd always be out in front, no matter what direction you were going in. The other possible use for this would be, for example, if you got into a fight, right? So we would be able to determine the direction that enemies are from us. So if I'm driving my scout around and I've got some, I've got some other bots following around with me, and then I run into some enemies, and I want to like readjust my formation based on those enemies that I've crossed, then, maybe my transport bots could run further away. So say, we're walking around here, and then, there's an enemy right here. You don't necessarily want your formation to now be working based on the direction you're moving. You now want it to be working based on the direction that your enemy is from your formation. And so you can now take your scout as the origin, your enemy as the reference, and then adjust your formation based on that directionality. So there's a lot of cool stuff that can be done for moving your bots around based on that directionality information. The other thing that could be useful is for scouting, identifying the directionality of where you want to go with your scouts so that you can adjust, again, your offset rotation from your central point. So maybe your command center is your central point, and it goes out and just starts randomly picking some different stuff, trying to find an empty space that hasn't been discovered yet at a specific distance. And then it finds it, and then, it can send that to your scout, and then its offset can be changed based on where it's going. So it can find, like its best possible path. You can do it with buildings, right? If I had these two buildings here, and I maybe wanted to add some additional storage or something, then I could use directionality to determine where the next building. So maybe I had like one storage right here. Then I know that my storage is moving in a south direction. So if I want to add another storage, then I could use that directionality to move the offset down this way and keep adding storages for this right here to keep spitting things out into. And I'm sure there's lots of other things that you could potentially run into. But being able to determine the directionality between 2 points is really important. This is also great because you don't have to use the bot running the program as the origin, right? I can set this fabricator as the origin and this as the reference, but I can do it from my scout. So if you were using like a centralized building controller, like your command center here, then that command center can query where everything is in reference to everything else in its entire visual area. So this command center can know the orientation of these two buildings or any other buildings that might be attached to it, and then decide based on that where additional buildings need to be built. So a lot of really good stuff in there, because that get location is not something you need to be right next to another unit to use. It can be done remotely. But yeah, so I hope everybody got some value out of this. I will be pasting the behavior down in not the comments, in the description, so you can just copy that behavior and just make sure you paste it in here. So you'll come over to it, you'll copy that crazy string of letters to your clipboard, and then you can just paste it right in. Make sure you use this paste item, because you have to use the paste item to get the parameters up here to paste over. If you just come over and hit V and paste in this information here, then it doesn't give you the parameters. So you need to use paste item right over here to make sure that it works right. But yeah, I hope everybody got some good value out of that. I hope that helped you learn a little bit about how some of the behavior nodes and stuff work, and how maybe you can use some of the math nodes and some really basic mathematics to do some pretty strong things in this game. Like I said, I'm not a programmer. This is just a behavior basics series, and I'm kind of learning as I go here. But even with a fairly limited knowledge, you can get some pretty good stuff going on. So if you enjoyed the video, don't forget to hit the like and subscribe, and I will see you all on the next one.